Welcome to video clip 4.2, in which we discuss subprocesses and boundary events. So subprocesses can have boundary events, just like activities can have boundary events. We discussed the semantics of boundary events already in week 2. And now we want to transfer what we learned in week 2 regarding the boundary events of atomic activities, tasks, to boundary events of subprocesses. So if a boundary event occurs during a subprocess, the outgoing flow of the event is signaled, and either the subprocess is interrupted, if it's an interrupting boundary event, or the subprocess just continues normally in case it is a non-interrupting boundary event. When the subprocess starts, the process begins listening to the event, because we said that the event is only relevant if it occurs while the process runs. So once the subprocess starts, it starts listening to the event. If the event occurs, I need to react. And when the process terminates, the process stops listening to the event. The subprocess, maybe a bit more concrete, the subprocess stops listening to this event. Of course, it's the process infrastructure that listens to the event. If during execution of the expanded subprocess obtain material and manufacture product, that we see here, a boundary event occurs, the subprocess is interrupted. And this is a slight variation of the scenario of the process we have been discussing before. So let's look at that. So we can attach, use the highlighter here. Here we have the attached event, or the boundary event as it is called now. So if this event occurs while the subprocess runs, we need to, in this case, cancel the order, just send a cancellation of the order. We do not further specify where does this event come from. So if this event is caught by the subprocess, then all activities that are executed in the process are stopped, or that are currently executed are stopped. All activities that should be executed further will be skipped. They are no longer required, and the subprocess is interrupted. All right, let's talk about subprocess and reuse. So subprocesses can be reused in a number of process models by using so-called call activities. You know, an activity, a subprocess is also an activity. So a task is an activity and a subprocess is also an activity. And a call activity is globally known and can be referenced in any business process model, and also, of course, several times. The notation of a call activity is an activity with a bold border. And upon execution, the call activity is invoked in the context of the calling process. And there are also, as I mentioned before, atomic call activities. So we can have the following situation regarding the example. We here have a collapsed subprocess called ship and settle. And as we see by the bold border of this subprocess, collapsed subprocess activity, that is defined somewhere else. So there is that's basically is a reference to the point where it is defined, and it can be defined in another process model. Here we have the same name, ship and settle, and also here it's used as the bold border, and then you see it is defined here and used in other places. So by discussing subprocess, we also said that a subprocess is basically a reference. Subprocess activity, collapsed subprocess activity, is a reference to a process model where the subprocess is defined. Yes, that's true, but if it is not a call activity, it can only be referenced by the calling subprocess, and not by others. And if it's a call activity, then it can be referenced from anywhere else. There are also ad hoc subprocesses, and ad hoc subprocesses are used for parts of business processes that do not have this strict process structure that we normally talk about. So sometimes activities may appear in any order and also can be repeated until some condition is met, satisfied. And therefore the ad hoc subprocess is used, and it groups a number of activities, like we have seen here. So we have an example where we have, first of all, the event order received occurs. Then we have this ad hoc subprocess. Again, it's a subprocess structure. And it has two activities, one of which is a subprocess, or the verify order process is a subprocess. Inquire order status is just a task. And that means that these two activities can be executed in any order or even overlapping. And so there's no strict execution sequence between these two. The ordering and the number of executions is determined by the performer of the ad hoc subprocess. So it can be, even inquire order status can be invoked, can be started multiple times. I can inquire often about the order status, and this, of course, is what we also see in real-world processes. And the activities do not need to be sequential, they can overlap each other. There is a completion condition that defines if and when the subprocess should terminate. That is used as an attribute. bpmn has attributes, and this is also one of the attributes that is associated with the ad hoc subprocess. Here we use an annotation to show the explanation or to explain this condition, and we use that completion order is verified. So once the order is verified, that's the completion condition. I can move on and I can come to the other parts of this process. A modeling guideline that is associated to subprocesses. We need to ensure consistency of events of a subprocess with those of the parent process. And that's motivated as follows. A subprocess can be started when the subprocess activity is signaled. When it is in the ready state, it can be started. The subprocess may only start with a blank start event or with an activity. So you can even not use start event in the subprocess, because it's clear when the subprocess can start, and that is when the subprocess activity in the collapsed subprocess activity is in the ready state. Then the subprocess can immediately start without waiting for other events to happen. Subprocesses with more than one alternative blank end event shall be followed by an XOR gateway. So when there are two possible outcomes of a subprocess that are not further detailed, then probably these different outcomes have implication on the process level, and therefore the next activity on the process level should then provide this branching that either one way is taken or the other way is taken, depending on the outcome of the subprocess. Non-blank end events, or error end events, must be caught by boundary events attached to the subprocess activity. So if it's a non-blank end event and there's events thrown at the end of the subprocess, then these events need to be caught by the boundary to provide, let's say, the scope of the event handling here. Okay, so let's go into this a bit more detailed, and also using an example. So subprocesses and blank end events. So subprocesses with more than one alternative blank end event shall be followed by an XOR gateway in the parent process. So let's try to sketch that using the pen. Again, an ABC process, activity A, then we have subprocess starting with B. I do that as an expanded subprocess. Then we have a decision. Either we go C or we go D. And here we have the two alternative end events. And of course, that's the complete subprocess. And then what this guideline says, that if we have this situation, then after executing this subprocess, either this event occurs, let's highlight that, either this event occurs or that event occurs. Either of the two must occur. And the outcome of the subprocess has an effect on the process level, on the, let's say, top level of the process, so that there we will have one alternative for each of these alternatives. So this association here, and association there. So that makes it clear that the outcome of the sub-process has an implication on the process level as well. That's what's meant here with this guideline. Events can be thrown from within the sub-process to be caught by the sub-process boundary. And also there is a typical example that structurally looks quite similar. So let's also, try to sketch that. So there is a start event and activity A. And then we have the sub-process starting with B. Then we have either a C or a D. Okay, that should be a C. After the C, the process normally terminates. After the D, we have an error event, an error end event. Yeah, so if D occurs, then that indicates an error. That should not occur. That's not the correct end of the sub-process. So there is an error event thrown here. And now that is a sub-process that would normally continue with E. The sub-process has these boundary activities. So let's just draw it. We'll just draw it here as a boundary event, the boundary error event. And once the error occurs, I do something else. Yeah, handle error. Handle error activities here. And there the process terminates, for instance. Okay, so in this situation, what happens, there are two outcomes of this sub-process. One outcome is a normal outcome. In that case, the process continues with E and with the normal end event, the normal outcome of the process. However, let's try to get rid of that. Okay. However, the process might also the sub-process might also end with the error event. The error event is thrown. Oh, an error occurred inside of the sub-process. So what happens is that this error event is caught by the boundary event, and then the error handling occurs. And we have here the second alternatives, or the error outcome of the complete process. That brings us to an end of video clip 4.2, in which we discussed sub-processes and boundary events. We looked at boundary events, looked at, events that can be thrown. So boundary events throw an event in a sub-process. So the event is thrown in the sub-process and the event is caught at the boundary of the sub-process. And we looked at call activities. So call activities can be used, are, let's say, defined in one place and can be used by many other business processes. So that something like a macro that is then invoked or used in many different contexts. So the invocation depends on the context of the particular parent process. We took a look at ad hoc sub-processes which do not have an internal structure, where the activities can be executed multiple times without any execution constraints until the condition of the ad hoc sub-process is met. And finally, we took a look at modeling guidelines regarding boundary events.